All right, so this morning we're going to have a quick introduction to 2.4, solving absolute value equations and inequalities. We're going to focus on equations right now and then solve the inequalities later on Thursday. So the first thing we have to address is what is absolute value. Absolute value is the distance, and the key word here is distance, that a number is from 0. Now, distance is always measured as a positive value. You can travel 10 miles, and whether you go north, south, east, or west, it will still be 10 miles. So what that means is that whether we're looking at 4 or negative 4, they're going to have the same absolute value of positive 4. What this does when we start solving equations, when we start seeing our variable inside the absolute value symbol, it means that we've got to account for the potential positive answer and the potential negative answer. So we'll see in this first example, we've got our absolute value of 3x minus 7 equals 12. Well, that means that 3x minus 7 could equal positive 12, or 3x minus 7 could equal negative 12. As we start to solve, it's not going to change anything about how we solve our equations. Both cases, I'm going to add 7 to both sides. But because we've taken a positive 12 and a negative 12, it's going to lead to different results on the right side of our equal sign. Similar, it doesn't change that we're going to divide by 3 on both sides, but it's going to lead to 2 separate answers, 19 thirds and negative 5 thirds. From here, only a couple more things can really happen when we're dealing with an absolute value. We can have values outside the absolute value. And in those cases, we try to isolate the absolute value before we start taking our 2 cases. So, in example 2, before I can start identifying the potential positive and negative absolute value, I've got to add 4 to both sides. Once I've added 4 to both sides, I end up with the absolute value of 2y minus 9 equals 3. And now that my absolute value is isolated, I can set up my 2 separate equations. 2y minus 9 can equal 3, or 2y minus 9 can equal negative 3. And again, once we've set up our 2 separate equations, it's not going to change the fact that we're going to add 9 to both sides. But because we had a positive 3 and a negative 3, it's going to lead to getting 2 different potential values on the right-hand side. And similarly, when I divide by 2, it's not going to change the fact that I'm dividing by 2 on all the sides. But because in one equation 2y was equal to 12, and in the other equation 2y was equal to 6, it's going to result in 2 separate answers, y equaling 6 or y equaling 3. In the third example, we can see that we've got negative 3 times our absolute value. And as if we were trying to solve the absolute value as if it was its own variable, my first step is going to be to divide both sides by negative 3. This is going to isolate my absolute value, which means that I'm now ready to set up my 2 separate equations. 4 minus 5t equals 6, or 4 minus 5t equals negative 6. Again, as I go through and solve, it doesn't change that in either equation I'm going to subtract 4 from both sides. But like we saw in the previous 2 examples, it does mean that I'm going to end up with 2 separate answers because I'm going to end up with 6 minus 4, which leads to 2, or negative 6 minus 4, which leads to negative 10. And so from there, in both equations, my final step is to divide by negative 5. And I end up with t equals negative 2/5, or t equals 2. Finally, we could end up with both scenarios from example 2 and example 3 in our equation, where we see that our absolute value has something being multiplied by it and something being added to it. So, as if I was solving for the absolute value as a variable, first thing I'm going to do is subtract 7. Once I've subtracted that 7, I get negative 2 times my absolute value of x minus 8 equals negative 6. And again, I'm going to continue to isolate my absolute value. So I'm going to divide by negative 2, leaving me with absolute value of x minus 8 equals 3. And now since my absolute value has been isolated, I can set up my 2 equations. X minus 8 equals 3, or x minus 8 equals negative 3. From there, I only have one step to go to solve my equations. I'm going to add 8 to both sides. In the case where I've got 3 plus 8, I get x equals 11. But in my other case, negative 3 plus 8, I get x equals 5. Now the work we've just seen isn't going to change much when we start dealing with inequalities, barring one step where we have to remember to flip our sign. All right, hope this helps. Take good notes. We're going to have a brief quiz on this when we return on Thursday, very similar to the homework quizzes. See you Thursday.